Alright, this is lesson 5, domain and range for Algebra 1. Okay, so in math, we talk about domain and range. These are two big numbers, and they talk about the limits of things, meaning like how small does a number get, how big do numbers get in math. Because sometimes we don't want to include all the numbers because we want to limit it, okay? And so we're going to talk about what's a domain and range, and we're going to talk about functions. So kind of a lot of new things. We're trying to say how big and small things are, right? So kind of like let's say you're making a video game, okay? For your iPad. Are you gonna show your player the whole map of the one level before, or are they only gonna see a little limit of it, or a little bit of it, as they go through it? What do you think? Would you want to? What's that? Depends on the game, right? Sometimes you want them to see the whole map, and it's a huge map. Sometimes you don't want them to. You might want to limit just a little bit, okay? Same thing in math. There's limitations to how wide a graph is and how tall it is. Okay, so that's the first concept. This other concept is called a function, meaning it's like a machine. Okay, the way that I describe a function, it's a math machine. Okay, so let's say I had a machine in my room. It makes all sorts of things. Okay, you just put ingredients in and things pop out. Okay, so what happens if I put in? I'm going to put in flour, sugar, butter, baking powder, chocolate chips. Yeah, I'm going to put it in, the machine starts working. 10 minutes later, what comes out? Chocolate chip cookies. Delicious, right? Okay, and I'm like, this is awesome. I'm going to put something else in there. So the next thing I do is I go get some tortillas. I get some carne asada, like not cooked, just kind of like go get a slab of meat, and then I go like get some tomatoes and like onions, limes, cilantro. Okay, all sorts of good things, and then I put it in there. What's gonna pop out? A taco. Okay, maybe a lot of tacos. Okay, does that make sense? If I were to put in all the ingredients for a taco, would a cookie also come out? No. How about like a camel? Would a camel come out? No, it doesn't work like that. The way it functions, the machine, it needs to function. I put things in, a few ingredients in, and only one ingredient will pop out, or one product will come out. Does that make sense? Same thing with a math machine. I could put all sorts of ingredients into an equation, only one number should pop out. Only one number should pop out. Does that make sense? You following me? Yeah?
Yes.
Okay, good. Making sure. That's just some concepts that you need to know. Alright? So here are the steps for today if you're on the video. Identify your X and Y's in a table. Graph your table on a graph. Create a mapping diagram. We're going to talk about that. Identify the domain as the smallest number of the X's to the biggest. Identify the range as the smallest number of Y's to the biggest. And then functions only have one output per input, okay? So, here we go. Watch me do numbers 1 and 2, and then we'll go from there. Okay, number 1. So these are X's and Y's, so we know that the first number here is an X, the second number is a Y. So we have all of these numbers. We have 4 points here on a graph. So the first thing I want to do is I want to identify my X's and Y's in a table. So I'm going to make a table. The way you make a table is you just make like a table like this. Put X's on one side, Y's on the other side, and we're just putting them in. We got -6, 4, and I'm starting with the smallest X. The next smallest X is -2, 3, +2, -4, and last one is 5, 6. Okay. Okay, the next thing I want to do is graph my table. So, the way I graph it, just make an XY graph. It doesn't have to be perfect. I go to -6, 4. Let's go 1, 2, 3, 4, 5, 6. Up 1, 2, 3, 4. Plot a point there. That's my first point. Second one is -2, 3. It's about here. Next point is 2, 4, or 2, negative 4. 1, 2, down negative 4, 1, 2, 3, 4. Plot a point here. Last one's 5, 6. Okay, so these are all my points that are on the graph. Okay, next thing I do is create a mapping diagram. Okay, what that means is the following. I'm gonna go back to my original table, and I'm looking at whenever I put negative 6 into this equation, whatever it is, what number is going to pop out? Well, it says negative 6, 4 is going to pop out. So I have to make a diagram showing that. So this is what your diagram should look like. Oh. Okay. And what it's saying is if I put a negative 6, I'm going to get a 4 out. Okay. So I'm going to draw an arrow from 6 to 4. That means, like, remember when I put in all the ingredients for a taco, what came out of the other end? A taco. Does that make sense? So when I put a negative 6 into this equation, a 4 will come out, okay? If I put negative 2 in this equation, a 3 will come out. If I put in 2, a negative 4 will come out. Whoop. And if I put in a 5, a 6 will come out. Okay? And so that's a mapping diagram. So we've done 3 things. I made a table, I made a graph, and now this is a mapping diagram. One last thing, we have to figure out domain and range. Domain is the smallest amount of x's to the biggest amount of x's. So looking at all my x's, which one's my smallest number of all the x's? Negative 6. So then I would write domain as d colon negative 6. And then I think about what the biggest x is. It's 5. And then I'm going to put brackets around here like that. The range is the same thing, except I'm going to write r instead. And I'm thinking, what's the smallest y? What's the smallest amount of y's over here? Out of all this whole list, what's the smallest? Negative 4, good. And what's the largest? 6. Okay, and I do the same thing. And that's it, okay? And then we know this is a function because no matter what number I put in as an input, there's only one output, okay? Just like if I put in ingredients for cookies in my machine, what's going to come out only? What's the only thing that should come out? A cookie, right? I shouldn't get a cookie and a hamburger, right? Does that make sense? It wouldn't function properly. So the same thing here. We know these are all your x's are always your inputs. Your output is your y's, okay? So as you can see, there's only one output for each input. Okay, that's number 1. Questions on number 1? I'm going to do this one more time for number 2. Watch again, okay? Same thing. I'm going to organize all of these numbers in all of these ways. So the first thing, I'm going to go a little more quickly now because I think you're starting to understand it. So the first thing I do is make a table, XY table. So on your homework, you would do an XY table. Draw X, Y, starting with the smallest X here. Looking here, I got, smallest one is 3. So I'm going to start with 3, 5. Next one I'm going to do is 3, 2. Next one I'm going to do here is 4, 6. Next one I'm going to do here is 5, 2. And then 5, 3. Okay? Then I'm going to draw a graph with all of these points. And I'm just going to go quickly here. It doesn't have to look perfect. Okay, 5, 2. I'm going to go over 5, up 2 about. The next one is 3, 5. I'm going to go 3, up 5. It's about here. Next one's going to be 5, 3, which is right above the old one, right here. 4, 6, which is like right here. And then 3, 2, which is down here. Okay, I'm noticing all my points are right there. Next thing I'm going to do is make my mapping diagram. So you're drawing a box. It looks like this. Drawing a line in the middle. And then you're going to start writing the numbers down. The first one, the smallest input I'm going to put in is a 3. What happens if I put in a 3? Well, one of the outputs will be a 5. But I will also get an output of 2. So I'm going to organize my outputs a little bit. Smallest input is 3. Biggest output is 5. So my inputs are 3, 4, and 5. my outputs are, smallest output is 2, then it's 3, 4, and 5. Now look at this math machine. Look what happens, okay? Smallest one is 3. What happens if I put in a 3? I get a 5, so I'm going to draw an arrow from 3 to 5, right? And then I also get a 2, so I'm going to go 3 to 2, right? Then if I put a 4 in, I get a 6. Oh, I actually know how to put a 6. Wow. Okay, and then I'm going to put in, there's nothing else for 4, and then we 5, 2. And 5, 3. Okay. Now, what do I know about my machine for it to function properly? How many outputs should it only have? 1. Okay, now look what happens here. How many outputs does 3 have? If I put the ingredient of 3 in, how many outputs does it create? 2. So is this a function?
No.
No, so this is not a function, okay? So I would write not a function. Because it's really not a function. It's not functioning correctly. It's like a machine you're trying to make cookies, and it's producing cookies and chorizo, right? Do we want it to produce cookies and chorizo? No, because something's broken, right? That'd be weird if you did that, okay? Anyways, it's not a function. Now we're going to do our domain and range. We're going to take our smallest x's, which is 3. And the largest x, which is 5. And then we're going to do a range. Smallest y, which is 2. And smallest y, which is 6. And that's it. Does that make sense? Yeah? Okay. So there's a lot of writing. So on your notes, number 3. Okay, number 3. Not worrying about number 4 right now. Okay, so let's start off with the mapping diagram. So we're doing this right now. I'll give you 2 minutes to create a mapping diagram. The graph, table, graph, mapping diagram. Tell me if it's a function, and then tell me domain and range. Couple minutes, ready, go. So, XY table, this is what we need to do, is just start with the smallest x's and go to the largest one. What's the first smallest x for the XY table?
0.
0, okay. So you put 0. And then what's the output for 0? 1. Okay, are there any other zero inputs out there? No. Next largest x. What's the output?
3.
Are there any other outputs or inputs with 1? No. What about the next x?
2.
2. What's the output if I put 2 in?
4.
Good. And I keep doing that, right? So you should have 3, 1, and 4, 4. Okay? Raise your hand if you did this correctly. Okay, good. Super easy, right? Then we do our our graph. So we go 0, 1, draw a point. It doesn't have to be perfect. 1, 3. For today, it doesn't have to be perfect. When we have grid lines, it should be 2, 4, 3, 1, and then 4, 4. Okay? Raise your hand if your graph kind of looks like that. Okay, good. Then we have a mapping diagram. This one's it's similar to the table, but it's different. Okay, so let's do this. We're making our mapping diagram. Okay. What's the smallest x again?
0.
Next smallest x?
1.
Next smallest x?
2.
Next one?
3. 4.
4. Are there any other x's?
No.
No. So no. Do we have 5, 6, or 7, Gabby? No. Good. Okay. What about our smallest y's now? What about smallest y is?
1.
Next smallest?
1.
3. Next smallest?
4.
Okay. Let's look at just the y's. What's this?
2 ones.
No, but I just need to know it once. How many ones are there in the numbers? Just 1, right? So we just need to have it once here. 1. Okay, I'm sorry. Up front here again. What was the next one?
3.
3. Then the next smallest?
4.
Next one? Well, we already have a 1 here, right?
That's it.
That's it, right? Does that make sense? Okay, so let's think about this math machine. If I put a 0 in here, what number pops out if I put a 0 in? 1. Do any other numbers pop out with 0? Okay, what happens if I put a 1 in my math machine? What number pops out? 3. Good. What happens if I put a 2 in my math machine? What pops out?
4.
Good. What happens if I put a 3 in my math machine? What pops out? Okay. So I draw an arrow to 1. Are there any other numbers that pop out? No, good. What happens if I put a 4 in my math machine? What pops out? 4. Good. Okay, I got a question for you. Think about this. Is it a function, yes or no?
Yes.
No, it's not.
It is.
Why?
Because for every input, there's one output.
Good. For every input, there's one output. Did y'all hear him? So is it a function?
Yes.
Yeah, for each one of these, there's only one output, right? If I put ingredients for a cookie, or for cookies in my machine, what should pop out? Cookies, right? So for each, let's say this is the ingredients for, let's say this is the ingredients for cookies here. It outputs a cookie, right? Right? This is the ingredients for, this is also the ingredients for cookies, but it's for different cookies. These are for oatmeal cookies. Or I'm sorry, this one's for oatmeal cookies. What pops out? Just cookies.
3 go to 1. Shouldn't it be 3 equals, like, if it pops out, there's nothing there. It's 3 equals 3. It's not 3 equals 1.
For every, say it again, for every.
For every input, there's one output.
Okay, that's what,
3 and 4 have nothing there, though.
the numbers are irrelevant. You have to think about the concept. For every input, there's only one
But
output.
there's only 3.
Listen right now. For every input, there's one output. For each of these inputs, there's only one output. How many ways does 4 go? How many arrows come from 4? Only one. There's only one output, you see? How many arrows come from 3? Gab, you see only one arrow comes out. How many arrows pop out of 2? 1. There's only one output for every input. That's the rule for a function, okay? Yep.
So for it to be a function, you can only, every number should connect once?
Yes. Okay. Now let's just say 0 had 2 outputs. Is it a function? No. Or 2 arrows. When you see 2 arrows come out of a number, then it's wrong. Okay. So this is a function. What's our domain? 0 to 4, right? Because those are the smallest 0 to the, or smallest number to the biggest number for x's. What's our range?
1, 4.
1, 4, right? That's it. Does that make sense? Okay, so I'm going to stop there for the sake of time. We're running out of time.